Hi, this is Shakil Ahmed. In this tutorial, we will discuss about multiple linear regression. Multiple linear regression, we are interested in steady variable, dependent variable with two or more dependent variables. So we are interested basically uh, adjusting for confounding variables that confound the effect, basically that uh, can be adjusted during your regression model. In most of the situation, some covariates affect both the outcome and the exposure. So we need to adjust for that variable in our model. And in some cases, we are interested in analyzing the joint effect, how the two variables are affecting the very. We want to improve the predictive ability of a model, including different predictors, possible candidate predictors. That is called exploratory data analysis. Basically, we want to explore the factors affecting an outcome. So, in all these cases, we are interested in running a model with a single dependent variable and two or more independent variables. Independent variable, this is the case, we call it multiple linear regression or multivariable linear regression, not multivariate. Multivariate is basically used when we have a independent variables. But here we have two or more independent variables with only one dependent variable. So we are talking about the uh, mul- multivariable linear regression or multiple linear regression. So let's do this in Excel. We are interested in uh, finding the effect of BMI on blood pressure of an individual. I also want to adjust for age. Basically, the relationship between BMI and blood pressure may be affected uh, by the age of respondent. It is higher. It may have higher impact for younger individuals or lower in between male and female. So we can adjust for age and sex and other related demographic variables while assessing the association or relationship between BMI and blood pressure or BMI and heart disease and other outcomes. But we are talking about the linear regression. So the BMI is a quantitative variable which is uh, uh, a response variable, and we assume that this is related with the age, sex of the individuals. So let's start again. We have the data analysis tool back, and we again go to the option of regression, and we select the response variable and the age and sex. So we can select we can select BMI, age, and sex. So these all the variables in X should be adjacent to each other. We should in adjacent columns, otherwise it will not work. So keep in mind. And then you can again construct a confidence interval with marking on this, and you can uh, save your result on a new worksheet, and you want to show the standardized residual and residual plots and also uh, produce a fit line plot, and you can check the normability of the uh, residuals. So let's Y range must have the same number of rows, sample values regardless of labels. I think we have selected uh, one less value in Y as it was started from 2 and ended at 30 instead of 30 first. So you can just, okay. Now you can see the results. These are the normal probability plot that shows the normality of the term as we discussed earlier. And this is the relation residual plot for uh, variable x3, as variable x3 is binary. We have two portions, and this is somehow like uh, linear, but still we can't say it's a linear relationship. It is also there is a weak relationship between x1 and residuals as well. So now come to the regression model. Again, the R square is very low in this case with only 0.1%. Variations are explained by x, by the variables. And we have three variables, and unfortunately all the three variables are insignificant in this case with p-values zero point 0.8, zero point 0.9, zero point 0.9. But how we interpret this result if it was significant? This is the intercept. Intercept is the basically the average value when all the variables are on their level. In case of categorical variable, the values are zero when variable is continuous. For example, when age is zero and sex is at zero, it means sex is its reference level, and the BMI is also zero. Then the mean blood pressure is 144.8, and this is 142.13. Sorry, and this is one, that is the coefficient corresponding to variable x1, and that is body mass index, which we have explained. So this is the effect of basically the with 1 unit change in body mass index, the blood pressure will be changed by a zero point 0.1. That is other variables zero reference categories. Basically, controlling for other variables, and we are just other two variables, sex and uh, age. So we are interpreting the result for BMI. Similarly, we can do the interpretation for age and for sex. For sex, the interpretation is somehow different. For example, it's 0.061 means that the mean blood pressure in males, if we just assume that one is male, zero for female, then this is difference between the mean between male and female. 0.06 difference in blood pressure of male and female. So this is very not significant. So these are the interpretation of the results, and this is overall performance of the result. Again, in the model is overall not significant as the F value is very small and square value is also very small. So it is a worst model. We should think of a way the improve the way which has a real impact on the dependent variable. We should include the so these are all about the multiple linear regression when we have more than two variables.